So guys, now we are going to start the next topic of the derivative application of derivative, which is increasing and decreasing function. Here, in the differentiable function, first we know about increasing and a decreasing function. So the meaning of increasing and decreasing function is function which is increasing means we can say about first increasing function. So increasing function. By the help of graph, we can say that if the function is increasing on the coordinate axis, which is x-axis, y-axis, here is the x-axis, is a y-axis, and on this coordinate axis, if y is equals to f of x, be any curve. So this is y is equals to f of x, be any curve. On coordinate axis, we draw a one curve which is y is equals to f of x. So here on this curve, the point P which lie on this curve at a distance x is equals to a, P at x is equals to a. So we can say that parallel to y-axis and perpendicular to x-axis, the distance of x, which is a, at x is equals to a. If the distance of left side of the point A and distance of right side of the point A, if we take del, which is del is a neighborhood of x. If we say del is a neighborhood of x, then we can say that the distance before the x-axis at x is equals to a, which is a minus the del, and distance after the point x is equals to a, which is a plus a del. So if this distance before point P, after point P, the distance before at x is equals to a minus del, distance after at x is equals to a, which is a plus del, and the coordinate of neighborhood at x is equals to a is a minus del and a plus del. We can say that distance of from origin, which is a minus del, is x1, and distance from origin a plus del, which is x2. So del is a small neighborhood and coordinate of neighborhood, consider a small neighborhood is a minus del, a plus del. So again about a, if we take 2 points x1 and x2, from above condition we can say that x1 is less than x2. It means that we can say about the functions, function of x1 is also less than function of x2, which is if the given condition function of f of x1 which is less than x2 or x1 less than x2, or we can say that x2 is greater than x1 or f of x2 is greater than f of x1, then this function is increasing at point x is equals to a. From this condition, we can conclude the definition of function which is increasing is are as follows. The definition of increasing function at x is equals to a, the function in form of x, increasing function which is in form of x. So the definition of increasing function is a function f is said to be increasing at x is equals to a if there exists some neighborhoods, del is a neighborhood here, some neighborhood before the distance at x is equals to a, which is a minus del, and a coordinate after the distance a at a point x is equals to a, which is a plus del, some neighborhood a minus del and a plus del of a such that for any 2 points x1, x2 in this neighborhood with x1 is strictly less than x2, we have f of x1 is less than or equals to x2, f of x2. So we can say that if the function f of x is strictly increasing at x is equals to a, then we can say that f of x1 is strictly less than f of x2. If the function is f of x1 is less than or equals to f of x2, then we can simply say that the function is increasing at x is equals to a. But the given function is strictly increasing at x is equals to a, then we can say that f of x1 is less than f of x2. Similarly, we can say about function which is decreasing at x is equals to a. So on the coordinate axis at x is equals to a, which is x-axis, which is y-axis, and y is equals to f of x be any curve. Here y is equals to f of x be any curve, the given curve which is y is equals to f of x, and there point P which lie on the curve and x is equals to a, here point P, here P be the point and x is equals to a which lie on the curve fixed point and x is equals to a, we can say that at x is equals to a, we know about if the point there is a neighborhood point P passing through this point which is a tangent, here the angle which is theta. So given curve y is equals to f of x, the distance before the point x on coordinate axis here which is a minus del, and before the distance which is a plus del. So the function which is decreases from the x coordinate, y coordinate at a minus del is x1 and a plus del is x2. From the above condition, we can define the definition of decreasing function is a function is decreasing, a function is decreasing at x is equals to a when its neighborhood which is a minus del and a plus, when this neighborhood a minus del and a plus del of such that for any 2 points x1 x2 in this neighborhood with x1 is strictly less than x2, we have f of x1 is greater than f of x2. So we can say that if function f of x is strictly decreasing at x is equals to a, then x1 is strictly greater than x2, or f of x1 is strictly greater than f of x2 when the function f of x is strictly greater than, strictly decreasing at x is equals to a. So now we have to discuss the main part of this topic. Function is increasing or decreasing. If the simple function, simple form which is increasing and decreasing at x is equals to a, then we can say that the function before the point at x is equals to a, which is a minus del x1. After the point x is equals to a plus del, which is at point x2, x1, if x1 is less than x2, if x1 is a less than x2, then we can say that f of x1 is also less than f of x2, then function is increasing. The second point, which is decreasing, if function at x is equals to a, before the function a minus del, which is x1, before the function at x is equals to a, after the function which at x is equals to a, which is a plus del x2, then we can say that function is, if x1 is strictly greater than x2, that is, we can say that f of x1 is strictly greater than f of x2, then function is strictly decreasing at x is equals to a. So here, similar, the main part of this topic, if the function is increasing and decreasing when the given function is in form of differentiable function. If the differentiable function y is equals to f of x is increasing or decreasing, how can we test the function is increasing or decreasing? So here, about the differentiable function, we can say that, or some point, if we have to test the function differentiable and it have increasing or decreasing, then some rules are as follows. We can say that if y is equals to f of x be a differentiable function, or simply we can say that if f of x be a differentiable function and x is equals to a, and if we can say the function f of x is increasing, then it satisfied the condition derivative of the function f dash of x is greater than or equals to 0. So after that, if the function f of x is decreasing, then we can say that the condition which satisfies the derivative of f of x, which is f dash of x, is less than or equals to 0. So again, third condition, if the given function is strictly function f of x is strictly increasing, then we can say the condition that it satisfied f of x is strictly greater than 0, not equals to 0. And fourth condition, which is function f of x is strictly decreasing, then f dash of x is strictly less than 0. By using these conditions of function which is increasing or function which is decreasing, if the function f of x is differentiable function, by using this condition we can test or we can verify the following functions which are increasing or decreasing. Then the first example of function which is increasing or decreasing are as follows, which is, it is so simple to verify the function which is increasing or decreasing. So the function, if f of x is equals to x cube plus 10x plus 7 is in the differentiable form and differentiate with respect to x, differentiable function in form of x, here we have to show directly the given function is strictly increasing at x is equals to a, and x belongs to real number. A means here x, which is the real number. So here function f of x, given a function, given that f of x is equals to x cube plus 10x plus 7. So you know about function which is increasing and decreasing. If the function f of x is differentiable function, and if we have to verify function which is increasing or decreasing, first we differentiate this function with respect to x. After differentiating, we get derivative of f of x. If this derivative of f dash of x is strictly greater than 0, then we can say that function is strictly increasing at x is equals to a, or x belongs to real number. So first we differentiate given function with respect to x. After differentiating, the derivative of f of x is equals to derivative of x cube plus 10x plus 7. So here derivative of f of x, which is f dash of x, derivative of x cube is 3x square plus 10 into derivative of x1 plus derivative of 7 0. Hence f dash of x, which is 3x square plus 10. Here 3 is positive, and if x be a real number which is positive or negative, square of any real number is positive. Hence we can say that this 3 positive and x square which is also positive, product of this positive which is also positive, means if the product of this function 3x square is positive, hence we can say that which is greater than 0. Strictly greater than 0, not a 0, strictly greater than 0. So again 10 is also positive number, and we can say about 10 is also strictly greater than 0. Hence we can say that whole function 3x square plus 10 is also 0. Hence we can prove that, hence we can say that function f of x, which is x cube plus 10x, x cube plus 10x plus 7, is strictly increasing at x belongs to a real number, hence proved. So again the next example, which is based on the increasing and decreasing function. Example number 2, test whether the function which is f of x is equals to x cube plus 6x square plus 12x minus 5 is increasing or decreasing for all x belongs to real number. If function f of x is a differentiable function, then it can use a result which the type function f of x, in first one f of x is strictly greater than or equal to 0. Here f of x is less than or equals to 0, or we can say that f of x is strictly greater than 0, or f of x is strictly less than 0. Here function which is increasing, function which is decreasing, here strictly increasing, and here strictly decreasing. So by using this condition, we have to test the given function f of x, which is increasing or decreasing. So here first we take given function, here given that f of x is equals to x cube plus 6x square plus 12x minus 5. After differentiating with respect to x, we can say the derivative of f of x, which is f dash of x, is equals to derivative of x cube, which is 3x square, plus 6 into derivative of x square, which is 2x, plus 12 into derivative of x, which is 1, minus, and the derivative of constant function, which is 5, is 0. So here we can write 3x square plus 6 into 2x, we can write this 3 into 4x plus 12 into 1, which is 12, minus 0. Here we can take 3 common from every terms. If we take the 3 common, we can write x square plus which is 4x, 4 into 3 which is 12, we can write 4. Here f dash of x is equals to 3 into x square plus 4x plus 4. But here we can't say exactly this function which is greater than 0 or less than 0, means positive or negative. Here if the given real numbers is positive or negative, then become, first we take x square plus 4x plus 4, which is rules of a quadratic form a plus b bracket square, quadratic form a plus b bracket square is a square plus twice ab plus b square. If we use this rule, here x square plus 4x plus 4, we can write this x plus 2 whole bracket square. Here we can say that if x is positive or negative, but square is always positive, hence we can write this. If x is real number and x is also 0, then 0 plus 2 is 2, it become positive. If this negative, then square of also is negative, which is positive. If this positive, the square which is positive is positive. Hence we can say that x plus 2 whole bracket square is always strictly greater than 0. It means that is we can write 3 into x plus 2 whole bracket square is strictly greater than 0. Hence from above condition 3 into x plus 2 whole bracket square is also greater than 0. Hence 3 into x plus 2 whole bracket square is the value of f dash of x, and we can write f dash of x is greater than 0, means strictly greater than 0. Hence we can say that therefore given function f of x is equals to f of x is equals to x cube plus 6x square plus 12x minus 5 is strictly increasing x belongs to real number when x is equals to real numbers. So here the next example number 3, and here we have to find the value of x, for which the function f of x is equals to x cube plus 12x square plus 36x plus 6. And here we have to find the value of x when it satisfies the condition. First, monotonically increasing means when function is strictly increasing at x is equals to a. And second one, which is monotonically decreasing, means function is strictly decreasing at x is equals to a. So here, now first we know about the condition of increasing or condition of decreasing. So here if the given function is f of x and it satisfies the condition of which is monotonically increasing means strictly increasing, then we can, monotonically increasing means strictly increasing, it satisfied the condition, we can write this, that is f dash of x is greater than 0. So again we can say about monotonically decreasing, that is we can write f dash of x is strictly less than 0. So first we take the derivative of f of x, which is f dash of x. If it monotonically increasing, that is it satisfied the condition of f dash of x is greater than 0. If it satisfied the condition which is monotonically decreasing, when we can say that f dash of x is strictly less than 0. So first we take the given function or given that f of x is equals to x cube plus 12x square plus 36x plus 6. Here we have to find the value of f dash of x, means derivative of f of x, and with respect to x. So after differentiating with respect to x, we can say that the derivative of f of x, which is f dash of x, is equals to derivative of x cube is 3x square plus 12 into derivative of x square, which is 2x, plus 36 into derivative of x, which is 1, and the derivative of 6, which is constant function, is 0. So we can write this 3x square plus 12 into 2, or if we can write 24x plus 36. If we take 3 common from 3 terms, here we can write x square plus 24 means 8 into 3, 8x, plus 36 means 12 into 3, 3 common from, we can write 12. Now we have to factorize this x square plus 8x plus 12. If we factorize this term x square plus 8x plus 12, then we can write the factor of 12 into 1, which is 12, and the factor of 12, here we have to 8, 2 into 6, plus 2 plus 6, 2 into 6 plus 12, 2 plus 6 plus 8, we can write x square plus 2x plus 6x plus 12. The factor of this fourth term we can write, if we take x common from first two terms, we can write x plus 2. If we take 6 common from both terms, we can write x plus again 2. Here x plus 2 is common, we can write in first bracket x plus 2 and second bracket x plus 6. So this whole function x square plus 8x plus 12, we can write in first bracket x plus 2 and second bracket x plus 6. So here we have to find the value of x by using these both conditions. The value of f dash of x, which is 3 into x plus 2 into x plus 6. First, if the function is monotonically increasing, by using this condition we have to find the value of x. First we have if function f of x is monotonically increasing, then we can say that f dash of x is strictly greater than 0. That is, f dash of x, which is strictly greater than 0, function is increasing, that is, we can write f dash of x is greater than 0, and the value of f dash of x, which is 3 into x plus 2, x plus 6, is strictly greater than 0. If we shift these 3 right side, then 0 into 3 also 0 upon 3 also 0, we can write x plus 2 into x plus 6 is strictly greater than 0. Hence we can write, then either the condition both first bracket greater than 0 and second bracket greater than 0 means x plus 2 is greater than 0 and x plus 6 is also greater than 0. Eitherly we can write x plus 2 is also less than 0 and x plus 6 is less than also 0. Here this condition divide into two cases, which is first case x plus 2 greater than 0, x plus 6 greater than 0. Second case x plus 2 less than 0 and x plus 6 less than 0. So if we have to find the value of x, then case first, which is x plus 2 is greater than 0 and x plus 6 is also greater than 0. If we shift this plus to right side, we can write x is greater than minus 2, and here also x is greater than minus 6. Thus we can say that, thus for every x greater than minus 2, x is equals to minus 2, or x is strictly greater than minus 2, function, a differentiable function x plus 2 into x plus 6 is strictly or monotonically increasing. Again, in second case, we can say that case second, which is both function x plus 2 is less than 0 and x plus 6 is also less than 0. We can say that here, if we shift this to right side, x is less than minus 2 and x is less than minus 6. Here we can say that, thus every x is less than minus 6, which is x plus 2, x plus 6 is monotonically increasing. So we can say that when x is greater than or equal to minus 2 and x is less than or equals to minus 6, all the numbers or all the values of x which is increasing, monotonically increasing at x is equals to minus 2 to minus 6. Hence from case 1 and case 2, we can say that from case 1 and case 2, we can say that function is monotonically increasing when x is greater than minus 2 and x is less than minus 6. That is, if we have to find the function f of x which is monotonically increasing when the value of x which is related x belongs to when x is greater than minus 2, the value of x which is greater than minus 2, which is minus 2 to infinity, and the value of x is less than minus 6, which is x belongs to, that is we can write x is greater than or equal to minus 2, x belongs to infinity to minus 6 when x is less than minus 6, which is a required value of x when x is monotonically increasing. Now we have to find the value of x when the value of x which is monotonically decreasing. Function, secondly, function is monotonically decreasing. We know about the condition of function when a monotonically decreasing, that is we can write f dash of x is greater than 0 or less than 0. When the function is decreasing monotonically, then we can say that f dash of x which is strictly less than 0. Here strictly less than 0, and the value of f dash of x which is 3 in bracket x plus 2 x plus 6 is also less than 0. That is we can write it, if we shift this to the right side, we can write x plus 2 x plus 6 which is less than 0. Then either we can write either x plus 2 greater less than 0 and x plus 6 less than 0, or we can write x plus 2 greater than 0 and x plus 6 is also less than 0. So here, if we take the first case when monotonically increasing, we can write x plus 2 is less than 0 and x plus 6 is also less than 0. So here x plus 2 is less than 0 and x plus 6 is less than 0. We can write x is less than minus 2 and x is less than minus 6. If the function is monotonically decreasing at x is x, therefore we can write x belongs to minus 6 to minus 6, minus 6 to minus 6. From the value of minus 6 up to value of minus 2, we can write the function is monotonically decreasing. Sorry, here in case second, case 2, function is decreasing at x is equals to a, x plus 2 is greater than 0 and x plus 6 is greater than 0. Here we can say that x is greater than minus 2 and x is greater than minus 6. Sorry, greater not, less than minus 2 and less than minus 6. Here the value of x which is less than minus 2 and the value of x which is less than minus 6 does not rise, or we can say that increase. You can check the reason of this value does not rise, which is monotonically decreasing when function x plus 2 is less than 0 and x plus 6 is less than 6. You can check a reason of this function, the value of x when is monotonically decreasing, which is x belongs to minus 6 to minus 2. When the function which is monotonically increasing, then x belongs to minus 2 to infinity and infinity to minus 6, which is a required value of x when the function f of x cube plus 12x cube square plus 36x plus 6 is monotonically increasing and monotonically decreasing.